All right, folks, I'm going to walk you through how to put three data sets on the same graph because we want to compare them to each other. So we want to have the same scale. This is worth 12. Oh, no, it's worth a lot more than that. 18, 21 points out of the 32 points in the lab, right? And I will, for this one lab, I will keep sending your graph back since it's a new skill until you get it right within a certain amount of time limit, okay? So the first thing you want to do is save your graph, but I don't think it'll let you do it until you put something in. Okay, so this is what you're going to do. You're going to do plus, we're going to add an item, and we're going to add a table, a data table. I strongly suggest the first thing you do is change this from x1, y1 to t1, x1, because otherwise you might do as I did and plug in the t where the x should go and vice versa. It's a little confusing because we want to do x comma y, but time is on the x-axis. All right, so we are assuming that we all started our stopwatches at the same time. So it was at x equals 0, at t equals 0. The other thing that's confusing is, you know, this y column is what you were given and the t column is what you measured. Okay, so that I just made up some data that should have the same shape. So you're just going to type in your data and you don't need to watch me do that. So we'll pause for a second. Okay, so I've typed in beautifully perfect data because, you know, I artificially created it. And then I love this function. A lot of people don't know about it. If you click on this magnifying glass, it will zoom to fit. And that way you can really see that this is a concave up parabola. Okay, so that was step one, was typing in the data and changing the headings. But we have to label the axis. That has to have more meaning. So you go to the wrench tool and your x-axis is really time in seconds, and your y-axis is really position in meters. All right, and then that's labeled. Awesome, free points. So we changed the headings, we made it fit. You can also make it fit by hand, but I love the little magnifying glass. And then we're going to choose a quadratic curve fit. Let's see. Yeah, I'm just trying to do this in the order that says on the graph, on the lab. So we're going to add an expression, and this may be new to you. This is how you do a regression line. I thought they added a regression line last year, but anyway, oh, that might be this up here. Yeah, add a regression. Let's see if that'll work. So we don't want linear regression, we want a quadratic regression. Awesome. That's one way to do it. I would like the color. It would be nice if the color of the graph matches the color of your data. So if you do that, you just click on this, you can make this green. In my case, since the data is perfect, you're not going to be able to see it. But that's great. That's one way to do a regression line. I'll show you another way to do it. You can add a expression, but what you're going to do is you're going to say, remember our variables are x1 and t1. You're going to say x1, and instead of equals, you're going to use the tilde, which is above your tab key. It's in the upper left corner of your computer. That means do a regression line, and that's going to equal a x1 squared. Looks like we're going to need to do plus b. Oh, no, that's because it's x1. My bad. T1. There you go. Okay, and so what it's telling you, this is what you're going to write down in the coefficient of time squared. It's telling you, because I artificially made that, that a is 0.5. So we get the same thing. What's in front of the t squared is 0.5. Okay, so I like my regression line a little better because it's saying that x is a function of t, whereas Desmos is just thinking y and x, which is not really as helpful in terms of explaining what you graphed. Okay, I'm okay if you do that, but you kind of lose, really it's x and t. So, but either one's okay with me as long as you know what it is. So what you were going to write down in your at the bottom of page 7 on your graph is the coefficient of time squared, but which is x squared here. So you're going to write down 0.5. We're going to see that tells you how extreme the parabola is. Okay, this is fake data. So I got a 0 for this number and a 0 for this number. You're probably not going to get zeros because you're not going to have manipulated data. Okay, that is the first data set, but we need to communicate what that is because we're going to have 3 graphs. So the other thing you're going to do is, this is pretty cool, pick any one of these points. It doesn't really matter which one. Again, your real data. Don't pick 0, 0. Pick something up here. So let's pick 1.3 comma 0.845. So just type that like a coordinate, and then you're going to label it whatever the first experiment was. This was experiment number 1, but maybe we want to say this is strong forward push, or we can just call it experiment number 1. Oops. Okay, awesome. Now we're going to add another data table. This is where Desmos gets really, really picky. I think that the x-axis this can't be x3. I think this has to be t1. And then this is going to be x2. I'll mess with this and make sure, but I won't have you watch it. All right, so I do think it's cleaner to do T2, X2, and it did let me do that. All right, so I typed in data for my fake data for experiment number 2, and you can see this is also a concave up parabola, but it's not changing as quickly because this is the experiment where we threw some friction in the mix. So the fan is pushing as hard as it was, but the friction is preventing the fan from speeding it up as much as it would otherwise. Okay, if our data is such that you need to rescale it so everything fits, awesome. Again, I think people know how to change that by hand. I also changed these from circles to triangles. You don't have to do that. I just did that to kind of make it visually different. Okay, so again, you can hit this little add regression line, except it's not a line. We don't want a linear regression. We want a quadratic regression. And and again, I got beautifully perfect data, so you're probably not going to see zeros there. But you can see this is what the green parabola is less extreme. It is closer to a line, which is the whole point of this lab, is the closer the forces are to matching each other, that the fan is pushing forward as much as friction is resisting, the closer that parabola looks like a line. Okay, so totally okay if you do quadratic regression. I think that you'll be happy with that. And again, you're going to take that 0.2, that's the coefficient in front of the t squared, and you're going to fill that in, you're going to add that to the box at the bottom of page 7. All right, we're going to do one more data set, and we're close to done. Oh, sorry, so you want to do add table, and then we're going to make this T3 and X3, and be with you in a minute. Okay, this is the data that is going to be the hardest to take. So some years this experiment works, and some years it doesn't, and you just have to trust me of what's supposed to happen. I'm going to change that from blue just to remind you of how you do that. Let's make that one orange. But this is what you're going to want to see, a concave down parabola from the first worksheet, that I started out with a slope, and the slope is decreasing. And then you will have other terms, I think, in your quadratic regression. Again, make sure you do quadratic and not linear. And you want whatever's in front of the x squared to go in the box in the bottom of page 7. And it should be negative because we have a concave down parabola. Okay, that may not mean a lot right now. So I don't quite have all of the points because I need a coordinate from each data set. So just as a quick review of how you do that, pick any point, not any point. You clearly don't want your labels to overlap. So maybe for this one, we want 0.586 and 0.4. So we're going to say 0.586 comma 0.4. And we want to label that orange graph experiment number 3. I don't really care if that's the same color. You know, we've got a blue label. I don't really care if that label is blue or, you know, I don't know why it's not letting me change the color of the label. There we go. Okay, so we got experiment number 1, experiment number 3, and then we have got to pick a point here. This one looks 1.3 and 0.338. So again, just type that in, 1.3, comma 0.338, hit close parentheses, and that I forgot to label is experiment number 2. All right, so again, let's save both of us some time in terms of having to get this sent back to you. Your axes must be labeled. Your experiments must be labeled. You need to have regression lines created. It needs to fill the page so that you, if it's all clumped up down, if it's too small, then you have trouble seeing that these are really parabolas. Okay, and then you can close this off if you want to see what it looks like. All right, so please save it as, you know, Miss Groppy rocks. No, just kidding. Save it as you rocks. No, just kidding. Save it as object and environment lab or lab number 1. You can save it with your name because when you go back to Desmos, you can open that up again and fix something. Hopefully you won't need to if I say you got to go back and fix something. Okay. I had to make this video. It disappeared over the summer. I think it has everything that you need. If it does not, I will not, you know, that'll be on me. I won't take off points, but please try to make sure. Let's get it right the first time. Save us both some time. Thank you for listening. You all rock. Bye.